In this session, we are going to discuss structure charts and what are the different components will be required while drawing the structure charts will be discussed in this session, and what is the difference between this DFD and structure chart also that will be covered. So, structure chart is a chart derived from the data flow diagram. So, in the earlier video we have discussed the data flow diagram. So, this video is in the continuation of that. So, it represents the system into more details than DFD. It breaks down the entire system into lowest functional modules. So, that is the main issue. So, it will have some representation where the lowest functional modules will be derived and describes functions and sub-functions at each module of a system to a greater detail which was absent in case of our DFD. So, structure chart represents hierarchical structure of modules and each layer a specific task is performed. So, let us go with some diagrams for the better understanding. So, here are the symbols used in the construction of the structure chart. So, let us start our discussion with module. So, it represents process or subroutine or a task. So, a module is nothing but a process, or it can be also called as a subroutine or a task. A control module branches to more than one submodules. So, whenever we are having some conditional statements are there, some conditions are there, then depending upon the condition true and false, it will be having multiple branches. So, library modules are reusable and invocable from any module. So, where the library means where we will be having some predetermined function bodies. The predetermined function bodies will be there in the library, and that very library module can be referred by multiple different other modules as when required. So, it is reusable. So, just consider this one. Here we are having this control module, and from where the controls can be transferred to multiple different modules. So, these are the sub modules and this is our library module. Let us we are going for the condition. So, it is represented by a small diamond at the base of the module. So, now you see this module is nothing but a process or a subroutine or a certain task, and here you see in case of structure charts the modules are getting represented using one rectangle, but whenever some condition is there then this diamond will be there at the bottom of this module, and it depicts that the control module can select any one of the subroutine based on some condition true or false. So, this condition is there. So, depending upon the condition true or false, so which module is going to get executed, we are going to get the control, and that will be decided. So, now also we have the jump. An arrow is shown pointing inside the module to depict that the control will jump in the middle of the submodule. So, now here you see this particular line is in the middle of this module. So, it is denoting a jump. So, this sort of representations can happen in our structure charts. So, loop, a curved arrow represents loop in the module. All submodules covered by loop repeat execution of the module. So, this is our loop. So, that is one curve is there, you can find this one. So, this is denoting a loop in the module. Now, the next one is our data flow. A directed arrow with empty circle at the end represents the data flow. So, now here you can find there is an empty circle and this directed arrow is denoting the data flow between these two modules. And the last one is our control flow. So, a directed arrow with a filled circle at the end represents the control flow. So, we are having the data flow, we are having this control flow. The basic difference here is that in case of data flow, this circle is empty, but in case of control flow, this circle is filled up. So, in this way, we had so many different symbols we have discussed. So, here we are having this module, and then here we are having this condition, depending upon the condition whether this condition is true or false, either one of the module will get executed. Then we are having this jump, this control line has come within this particular rectangular box. So, that is a jump statement, and this is our loop. We know this is a circle which is having the arrowhead is denoting the loop, and here you see within this particular this arc, these two modules are included. So, that means these two modules will go on repeating along with this iteration and looping. So here we are having this data flow, that is an empty circle with this arrowhead, and we are having this contour flow, that is filled circle with the arrowhead. So in this way, in our discussion, we have discussed what are the different components of a structure chart and how to use this one. Thanks. We are going to discuss HIPPO diagram. The full form of HIPPO is hierarchical input process output diagram. So hierarchical input process output diagram is a combination of two organized methods to analyze the system and provide the means of documentation. HIPPO model was developed by IBM in the year 1970. So HIPPO diagram represents the hierarchy of modules in the software system. Analyst uses HIPPO diagram in order to obtain high level of view of the system functions, and it decomposes functions into sub-functions in a hierarchical manner, and it depicts the functions performed by the system. Hierarchical means it will be having a tree-like diagram. So there will be one root, and there will be some branches are there, and with the leaf nodes and in between intermediate nodes. So here you can see that this each and every rectangle is denoting a module. So this module can perform a procedure, might be performing a task, or might be performing a process. So here you see we are having this online sales. So this is a module, and this module is having authentication, inventory check, payment process, and dispatch items. And this particular dispatch item, this module is also having the generate invoice, and these are the respective processes or the tasks or the procedures to be performed represented in this hierarchy of module structure. So HIPPO diagrams are good for documentation purpose. Their graphical representations makes it easier for the designers and the managers to get the pictorial idea of the whole system structure. So for this purpose, this HIPPO diagram is actually there. In contrast to input process output, we are having another diagram known as input process output diagram, IPO, which depicts the flow of control and data in a module. In case of HIPPO diagram, there was no scope to represent how the data is flowing, how the control is flowing. So that concept is not there. So HIPPO diagram is only denoting the whole system in a hierarchical view module wise. So HIPPO does not provide any information about the data flow or the control flow. So here we are having one input process output. So input process output diagram. So here we are just denoting the authentication. Input will be obtained from the user screen, and these are the processes are going to be carried out, and this is the output which will be obtained onto the user screens. So take authentication credentials from the user screen, check the validity of credentials, and call appropriate module, and output will be obtained on the user screen. So both parts of HIPPO diagrams, hierarchical representation and IPO chart, are used for structured designing of software program as well as documentation of the software program. So in this particular session, with proper examples, we have discussed what is one HIPPO diagram and what are the merits and demerits of it. Thanks for watching Structured English. We know that in the previous videos we have discussed HIPPO diagram, we discussed structured charts, we also discussed DFD and different types of DFDs and all, and there in all cases we had some graphical representations. Graphical representations are good enough, so there is no doubt, but different people can interpret graphical representations in their own views. So to avoid that anomaly, to resolve that anomaly, we are going to discuss this structured English. So most programmers are unaware of the large picture of the software, so they only rely on what their managers tell them to do. So it is not possible that everyone who are participating in that respective software development project will have the idea of the whole system, because the whole system is a very large one. So most of the people who are working involved in that particular project, they know that what the managers are asking them to do, so that much they can understand and that much is reachable for them. So it is the responsibility of higher software management to provide accurate information to the programmers to develop accurate yet fast code. So the communication between that manager and the respective subordinates working under his supervision, his or her supervision, the communication should be good, there should not be any miscommunication between them. So, different methods which use graphs or diagrams at times might be interpreted in a different way by the different people. So, hence analysts and designers of the software come up with tools such as structured English. It is nothing but the description of what is required to be coded and the how the coding has to be done. So, this structured English helps the programmer to write error-free code, and both the structured English and the pseudocode, it will try to minimize the misunderstanding, the gap between the communication between these managers and the respective developers and the coders. Structured English uses plain English words in a structured programming paradigm. So, it is not the ultimate code, but a kind of description that is required to code and how to code it. So, it will be not in plain English, but in some programming language paradigm it will be maintained there. The following are some tokens of structured programming: if, then, else, do, while, until. So, these are the respective phrases which will be used in our structured programming. Analysts uses the same variable and data name which are stored in the data dictionary, making it much simpler to write and understand the code appropriately. So, let us go for one example. So, we take the same example of customer authentication in the online shopping environment, which we discussed in our Hippo diagram and other diagrams prior. So, this procedure to authenticate customer can be written in structured English like this. So, enter customer name, seek customer name in customer name database file. If customer name found, then call procedure user password authentication, else print error message, call procedure new customer request. So, here you see this is the respective structured English, and it is almost in a certain programming language paradigm. You see here we are having this if, then, else, and if. So, it is quite similar with this Pascal. So, that is why the corresponding codes are there. So, the code written in structured English is more like our day-to-day spoken English, but it cannot be implemented directly as a code. It is not like that you can copy this code and directly paste onto the IDE and go on compilation. It is not like that. And of so software and the structured English is independent of any programming language. That means that irrespective of the fact that this particular software is going to get implemented in .NET or PHP or in Java, this structured English, this particular structured English code will remain the same. So, it is language independent. So, in this video we have discussed structured English. In this session we are discussing pseudocode. So, what is the pseudocode and how this pseudocode is getting differed from the structured English which we discussed in the earlier video. So, pseudocode is written more close to the programming language. In case of structured English, it is something like is our day-to-day English. In this form we wrote that one, but we have used some phrases which are very much alike or similar with the programming constructs. But this pseudocode is more close to the programming language, and it may be considered as augmented programming language, full of comments and the respective descriptions which are required for the developer, for the coder to generate the code appropriately and effectively and efficiently. So, pseudocode avoids variable declaration, but they are written using some actual programming language construct like your C or say Fortran or say Pascal. So, this is the respective constructs which will get reflected in our pseudocode. Pseudocode contains more programming details than the structured English. It provides a method to perform the task as if a computer is executing the code. So, in this way the pseudocode can be written. So, let us go for one example for the better understanding. So, here is one example for us. So, program to print Fibonacci up to n number of numbers. So, void function Fibonacci. So, reading this very line we are getting the flavor of C programming, but it is not a C programming. You see the function, after the function name there is no opening bracket, first bracket and closing first bracket. The function keyword is not there in our respective C programming. In our Fortran the function keywords are there. So, it is a mixture of this C, Pascal and Fortran program paradigms. So now get the value of n and then set the value of a to 1 and set the value of b to 1, initialize I to 0. So a is 1, b is 1, I is 0. If I is equal to 0, I less than n, I plus plus. If a greater than b, increase b by a, print b. If b is greater than a, increase a by b and print a. So in this way, we are trying to print the respective Fibonacci numbers through this pseudocode. So here is one sample code to represent that how the pseudocodes are getting written, and it is very close to the programming language. So coders, the respective developers can write the code in the proper syntax looking at this pseudocode very easily and comfortably. Thanks for watching. We are going to discuss decision table. Decision table is nothing but one tabular representation to denote the logic of a program. And in this particular case, whether the condition is true or false, depending upon that, what are the actions to be taken that will be represented using this decision table. So a decision table represents conditions and the respective actions to be taken to address them in a structured tabular format. It is a powerful tool to debug and prevent errors. So it is a very easy way to represent our logic and the respective actions to be carried out, and there will be no ambiguity to understand the logic and the respective actions. It helps group similar information into a single table, and then by combining tables, it delivers easy and convenient decision making. So decision table is actually used to represent our decision making processes. So creating a decision table. To create the decision table, the developer must follow the following 4 basic steps. So what are they? Identify all possible conditions to be addressed. Determine actions for all identified conditions. Create maximum possible rules. Obviously, I should not go for redundant rule creations, but whatever is possible in the respective business logic. So create maximum possible rules and define action for each rule. And decision table should be verified by end users and can literally be simplified by eliminating duplicate rules and the respective actions. Now let us go for one example for the better understanding. Let us take a simple example of day-to-day problem with our internet connectivity. We begin by identifying all problems that can arise while starting the internet and their respective possible solutions. So let us go for this problem in a tabular representation in the form of decision table. So we list all possible problems under column conditions and the prospective actions under the column actions. So here we are having these conditions and here we are having these respective actions. So what are the actions and conditions are to be represented, and there we are having these rules. We are denoting that one using the combination yes and no. So shows connected, ping is working, open website. So these are the 3 conditions we are having, and here we are having the respective actions. So conditions are there and the actions are there. So that has been depicted here in a very clear way. So when shows connected is not appearing, ping is working is not appearing, opens website is appearing, then check internet cable and check internet router. So these are the respective actions to be taken. So in this way, how many conditions we are having? We are having here 3 conditions. So if you consider yes and no for each and every condition, so how many combinations we are expecting? We are expecting 8 combinations. So you can find that 8 rules are there, you can find it, and the respective actions we are denoting that one. So similarly, I can also go for no, no, no for all of them, then go for contact service provider. So there is the respective actions to be taken. In this way, you can find that what are the different conditions and what are the respective actions to be taken that has been represented in a very easy way in a tabular format using decision table. So we have discussed decision table, we have given you one example for your better understanding. Thanks for relationship model is a topic in this session. We also call it as ER model. Entity is something which has got an independent existence in an enterprise, and relationship means how the multiple entities are getting related. So that is the origin of this entity relationship model. So let us go for the detailing on this ER model along with some examples. So, entity relationship model is a type of database model based on the notion of real world entities and the relationships among them. So, real world entities, I told you that entity has got some existence in the enterprise. We can map real world scenario onto ER database model. ER model creates a set of entities with their attributes and set of constraints and relations among them. With each and every entity, some set of attributes are connected. Depending upon the values of some attributes, an entity can be identified uniquely. So, whenever we are having alike entities, then collection of them will form the entity set. So, let us suppose we are having one student. So, in our college admission system, student is one entity, one course is one entity, one teachers respective details will be one entity. So, in case of student admission system or say in case of college administration system, so there we are having multiple entities coming in that way. So, with a particular student, as student is one entity, say roll number, name, age, gender, email address, phone number, contact address and so on. So, these are the different attributes are there. So, ER model is best used for conceptual design of database. An ER model can be represented as follows. Entities will be represented in the form of a rectangle. These attributes will be represented in the form of ellipse and these relationships will be represented in the form of this diamond. And these lines are showing the links between them. So, here we are having two entities, each one of them are having two attributes. Obviously, it is not mandatory that entities connected should have the same number of attributes. It can have 5 attributes, it can have 50 attributes. So, that is not a problem, and this relationship is actually connecting this entity and with that entity. So, entity is an entity in ER model is a real world being and which has some properties called the attributes, and every attribute is defined by the corresponding set of values called the domain. So, domain is nothing but a set of values from where you can pick up one value to instantiate one attribute. So, domain means actually the set of values from where you can pick up one value to initialize one attribute. For example, consider a school database. Here a student is an entity. Student has various attributes like name, ID, age and class, etc. So, now we are going for the relationship, that means this one, there is a diamond shaped box is there. The logical association among entities is called relationship. So, relationships are mapped with entities in various ways. Mapping cardinality define the number of associations between two entities. So, here we can have the mapping cardinality. Actually, we are having basically 4 different mapping cardinalities, that is one to many, many to one, one to one and many to many. So, here we are having the respective mapping cardinalities, we have described that one here. So, now let us go for some examples to explain how this mapping cardinalities are working. So, here we are having this one to many. Whenever we are having one, there this arrow will be coming. Whenever we are having many, there will be no arrow. Consider this one many to one. So, here many is having no arrow, but one is having arrow. So, that means one customer can have multiple number of loans, and against one loan there is only one customer connected. That means this bank can provide multiple parallel personal loans, because against one loan there will be one customer, so personal loan. Against one customer there will be multiple loan numbers, so multiple parallel personal loans can be provided. So, consider this one, multiple customers against one loan. So, against one customer there will be one loan, against one loan there will be multiple customers. That means here it provides the joint loan, there is a group loan this bank issues, but a customer who is having one of the loans cannot have the another parallel loans, because it is many but it is one. So, against one customer name there will be one loan, against one loan number there will be multiple customers name. Now, let us consider this one as one to one. So, both sides arrows are there. So, that is one to one. So, it depicts that one customer can have a single loan and only one loan at a time. So, many to many means multiple customers, multiple loans. So, that means that this particular bank issues parallel personal loans or group loans at the same time. So in this way you have described what is the entity relationship model with some proper examples and what are the different symbols we are going to use to represent and to draw this entity relationship model. Thanks for watching.